Today we're going to talk about the SQL create table statement. We're going to learn about how to use it, what questions you should be asking in order to create a new table, and by the end of this video you should be able to understand what's going on with this statement right here. So step one here, I want to first start with the syntax for the create table statement. So let me start a brand new query and let me bring that in. And this is the basic syntax. So it's pretty straightforward. There's not a lot of complication here. The trouble comes when you actually have to decide what to name your table, where you want to put it, what do you want in the columns, and how to make all those decisions. And we're going to walk through that today. But let's start with just creating a simple table. So all you have to do is type in create table, and then you have to put a table name in there. And so in this case, we're going to put employee as our table name. Then you have these two different parentheses, and then you start listing all your columns with all of their attributes. And let's just put in one column for now, and we'll just have an employee name column. And we'll make it a varchar, and we'll give it a size of, we'll say it can hold 50 characters. And if I execute this, we now have a table. Let me select back from that table. I'll highlight and execute that, and we have a table with one column. So that is the create table syntax. That's how you create a table. The real issue comes in with some of the other questions. So let me pull up my little presentation here. What I want to talk about today is, we talked about the create table syntax already, but I want to work more on what questions should you be asking when you're trying to put a new table in. There's going to be questions like, where should we even put the table? You know, what do we name the table? Are there any naming conventions that we should follow? How big is the table? How many rows are in there? Because that's going to help determine some of the modeling questions that you need to answer. Will the table be related to other tables? So is this going into a new database, or is it going into an existing database, so it's a supplemental table to something else? Then we'll work into what columns need to be in the table, and there's different questions you need to answer with those. The name of the columns, again, that's a naming convention thing. What type of data should be held in each of the columns? Can they be empty? Can they be null? And is there uniqueness? Is there a certain column that makes the row unique? Or do you need a combination of columns to make a unique row? And then finally, we'll work into who needs access to the table. So let's get started with that. Let me switch back over. Question number one, where are we going to put this? So that's the first question. So it needs to go into a database somewhere. I have a group of databases over in my SQL Server. And in this case, I chose to put it into an HR database. Whenever you're putting a new table in, you should also look and see what other tables are in there. Now, this is an empty database, so that answers that question. And since it's an empty database, I can design this table how I want to design it. If you are going into another database, for instance, if we come up to like AdventureWorks, there's some things we'll notice. In AdventureWorks, there are different schemas. So we got like a human resources schema, a person schema. I think there's more, there's production. And also what I notice when I look here is there's a naming convention. They start with capital letters for the very beginning of every word. They don't use underscores. So human resources doesn't have an underscore or a space. It's just a capital H, capital R. And then their table names start with a capital also. We're going to use a different naming convention. We're going to use underscores, and we're going to keep all of our table names with lowercase. And so we answered a couple of those questions. Where are we going to put the table? We're going to go ahead and put it in the HR database. Now, what do we name this table? So we're going to create a table that's based off of, we want employees in our company. So we're going to create an employee table. Now it's one word, there doesn't need to be any underscores. We made a decision that we're going to keep the first letter as lowercase, and we did not specify a schema. Now in SQL Server, the default schema is DBO. It's always good practice to put that in there. So that's the schema, dbo.employee. So we've answered where, and we answered what we need to name this thing. Now the question is, how big is the table? So this gets into the business. Is this table going to be, you know, do we have 10 employees? Or are we a big company that has 100,000 employees? Either of those questions are not huge. So when it comes to employee table, we're under 100,000 records. Now, if we were putting in some kind of trading table that was more of a fact or a transactional table, we might have billions of records. Now we're talking about a different size. We have to worry about tuning. We have to worry about the sizes of our columns. In this case, you know, some of the biggest companies would have 100,000 employees. Well, 100,000 records inside of a table is not necessarily a big table. So we're going to consider this a small table. Since it's a small table, we can make different decisions on how we want to size our columns. We can be more generous with the number of characters we put into the column and that we allow the column to store. If you have a huge table with billions of records, you need to be more exact on the number of bytes, the number of characters that can be stored. So we know this is a small table. The next question is, will the table relate to other tables? Well, if we're looking at the employee table, we can imagine that there will be other tables that relate to this one, where the employee table is the main table, but there's employee records. Maybe there's employee training, maybe there's employee insurance, or some other tables we ultimately create that need to know what employee that training or that insurance, what employee that relates to. So this could definitely be a primary key table for other tables. And so we need to keep that in mind as we get into the column section here, that this table probably needs a primary key that other tables can use. All right, now let's move on to the next questions. What columns need to be in the table? Okay, so first of all, let's put in a list of the columns we think we want, and then we have questions about each of those columns. So let's start with we have, in this case, we have an employee name, but we probably need that primary key. So we need like an employee number. Now I'm using our new naming convention where we're using lowercase for each word and we're using an underscore in between them. If we were doing something similar to the VentureWorks database, then we would have named this employee number with uppercase and uppercase. But we're going to do the underscore, and that's why you always look into the database to see what the current naming schema is so that you can follow that name scheme. Now, we don't know much about data types yet, so we're just going to make everything a varchar, and then we're going to come back and talk about the data types. And I'm just going to put varchar 50 here. And between columns, you're going to want to put a comma. We already made employee name, but I think we might like to have first name and last name. And let's do a last name one. We need our comma, and we'll do last name. Now we're in the employee table, and we could leave off employee on front of these, and we could just have first name and last name. It'd be a good practice to still have employee number as a column, but we could easily make a decision to just have first name and last name. We're in the employee table, so that should be enough. So we're going to do that. Now, what other columns might we need in an employee table? Well, let's go with like a job description. And again, we're just going to make everything varchar 50 for now, and we're coming back to talk about it. And then maybe we want to keep track of their manager. And when we keep track of their manager, we just want their number for now. Let's keep on going. Let's go with a hire date. We want to keep track of when they're hired. Again, I'm not picking data types. I'm just typing these things in, and then we're going to come back and pick the data types. And I think maybe we want to keep track of their salary. Okay, so now we have picked our columns. We've picked some names on these columns, and we've put underscore between them. We have a consistent naming convention. And let's move on to the next question that we would have. So that was the name of the columns. Now we're going to move into what type of data we want to put in them. Well, employee number is definitely not a string. Well, let's talk about the different types of data that you have, because you may not know all the different types. So what you're going to have here is you basically have a string data type that holds string values, and that'd be all your A, B, C, D, E, F, G, your alphabet, all the way, and it can also hold 1, 2, 3, 4, 5, all the numbers. But you can't do summations on a string. So even if you're holding numbers in a string, when you go to do like a summation or something, it says, no, it's a string. It needs to be converted to a number in order to do math things. And so a string holds characters. You also have numeric types. So you can hold numbers, and these are the things where you'd be able to sum. And then you have dates. Now there's other types, but these are the most common. We'll just start with these. Now inside of SQL Server, a string data type, you have a couple different choices to choose from. You have a varchar, and you have a NVarchar. The difference between these two, so the varchar is a single byte character. So it's a string that can hold single byte characters, and you would specify how many of those single byte characters are in there. So up here we said we want to hold 50 of those single byte characters, and that gave us a 50 character string limit that we could hold. Now the NVarchar, on the other hand, the NVarchar holds double byte characters. So we got 2 bytes. Up here we have 1 byte. And so the double byte characters, there's certain languages out there that need 2 bytes to store all the different characters in them. If you need those, you need to turn this into an NVarchar. Now an NVarchar, you need, since it's double byte character, if we want to store 50 characters, we would need to have 100 up here if this was an NVarchar, because each of the characters is 2 bytes. And so that would give us 50 characters. And that's the difference there. So for strings, it's varchar and NVarchar. There's a couple others, but I don't see them used really hardly at all. And so I would stick to, especially at the beginning here, I'd stick to varchar or NVarchar, depending on what you need. Now numbers, on the other hand, have a couple of options that are used quite often. So the numbers, we'll start with the most simple one probably, which is the int, which is a 4 byte integer. So you don't have any decimals on this type. You just have the actual numbers, no decimals, and it's 4 bytes. And there's variants on this int. Let me pull in a little help file here, just so we can take a look. The exact numerics, we have an integer, which we looked at, and I'm going to click over through here. We have the big int, we have the int, the small int, and tiny int. Now, you could always go after a big int, and you would be just fine. The only reason you'd pick one of these other ones is if you don't want to store so much data, because they all work. There's other things around indexes and things that you might have to take into consideration. But in the past, all we had was int, so we always picked int. And in here, it tells us as big of a number as you can store. And so on the positive side of an int, you can store up to 2,147,483,647 numbers. After that, it runs out of numbers for the 4 bytes. And that then comes in the big int. The big int can store, I don't even know what number this is, but it has way more numbers it can store. So if you're dealing with something more than 2 billion records and you're trying to have an identity column, you would have to go from int to big int. Now you also have a small int, which can store up to 32,000 characters. That almost looks like the number in Excel, the limit in Excel that used to be. And the storage is 2 bytes, and then you go down to tiny int, and it's 1 byte, and it stores up to 255. So that's the integer. Next up, if you need any type of decimals or any type of any type of decimal, there's 2 things that mean the same thing: decimal and numeric. And in here, the size depends on how big of numbers you put in this, and it always requires that you give it a total amount of characters you want, or numbers that you want. Say if we wanted 12 total numbers, and then how many numbers after the decimal. And we want to store 4 numbers after the decimal. This would give you 4 numbers after decimal, and then all you have left is 8 numbers in front of the decimal. So the biggest number that you would have would be, well, let's put our decimals in, 1, 2, 3, 4, and we'll come back, and then we would have 1, 2, 3, 4, 5, 6, 7, 8. We'll put our comma in, just so we know where we're at. So, and if we put this in, we would have up to 12 million is the most we could store. I'm sorry, 99 million. Ignore the numbers. These are just the decimal places. So 99 million would work. We couldn't go up to 100 million. And so let's take a look at what Microsoft says about these. We'll go back. So down here we have, or up here we have the decimal and the numeric. They're synonyms. You can use them interchangeably. But it also tells you, depending on your precision, we picked 12 for our precision, and the storage byte is going to be 9 bytes to store it. So as you go up into these different ranges, your column gets longer. And if you're modeling tables and trying to create tables, you need to understand how big that column is, especially if you get to data warehousing or big tables. In our case, I don't know if we have to worry about this yet, but I want to make sure you understand it. And so these are exact precision. And so anything under 99 million is going to be exactly stored up to 4 decimals. Now you also have your float. And a float is an approximation. It allows you to store a big range of numbers, but it'll start approximating them. So you'll start getting rounding errors when you start multiplying volumes times prices and things like that. You may end up with rounding errors. So this is okay a lot of the time, but if you get into like an accounting system, it becomes you'll want to use decimals if you can, but if your numbers get too big, then you run into an issue of, well, how do we want to store these and make them still exact? Okay, and then Oh, let me take a look at how big these are. It should be noted that if you put a float in and you don't put any size on it, it defaults to this 53, which is in value of 53, which gives you a precision of 15 digits, and it's an 8-byte storage. If you want the 4-byte storage of float, you have to go down to under 24 or under for the length of what you're storing, and it'll give you 7-digit precision. Okay, so the last data type I want to talk about, and then we can get back to creating our table, is the dates. For the longest time in SQL Server, all we had was datetime. And it would store a certain amount of date elements, but you would run out of days. And the date time stores both the date and the time portion. And now they've got something called the date time 2, which stores more. So you can go way back, not just to like the 1900s, but you can go back to 0000 for the year, where you have a cutoff to like 1900 is the min date. And so now we have date time 2. And we also have a date, which has no time portion. And then let's go take a quick look over here and see what else we have. And when we come down to dates, we also have this time, and then we have a small date time. Let's go take a look at that. Yeah, the small date time looks like it's a 4-byte storage size, and I haven't used it much, but your date range only goes back to 1900. And so those are the dates. So let's go back. Now that we know the different types, let's go figure out what we're going to put into our columns. So the employee number, we want some type of number here, and we could go with either a decimal number, and you could go 4, 0, and it'd be just like an integer, because it'd have nothing after the decimal, and it'd be a 4 characters or 4 bytes. 4 characters, but you'd only be able to store 1,000. The most common used here is the integer. And so that would give us up to, I think, what did it say, 2 million or 2 billion. And we know our employees are only going up to 100,000. So we're going to go with integer. First name, now we just have to imagine how long can a first name be. Well, since this is going to be a smaller table, we don't care as much about, putting a big number in here. But you could run into index problems if you go with too many characters. If everything you put 1,000 in here, there's a maximum limit of columns before you run into some indexing and some different sorting problems and things. So we want to get somewhat exact. I don't know of any names that are over 50. 100 would definitely cover it. I think we should just put 50 in here. Now I should mention, do we think we need 2-byte characters? In this case, I don't think we do. So we're going to stay with the Varchar and not go with the NVarchar. Last name, I think 50 characters is going to be enough. 75 or 100 might be safer. Job description. So a job description, how long do we think the job description is going to be? Do we think somebody's going to put a whole paragraph in here about the job description? Or do we think it's going to be something that you could put into a report? It's probably something you can put into a report. So 50 is probably enough here. And now we've moved into the manager number. Okay, the manager number, what do we want to do with that? Well, we want the manager number to actually be another employee number. So if you have an employee that, or a manager, well, they're also an employee, so they should be in this table. So we want this to be the same data type as our employee number. And we picked integer up here, so we're going to pick the same thing down here. All right, so now hire date. There's a question that we should ask here. Do we want to store the date and time that they were hired, or do we just care about the date itself? for the most part, I would guess that there's not an exact time of hire. There's just a date. It's not really like a timestamp or anything. So in this case, we're not going to put date time, because we could put date time, or we could put date time 2. Everybody's going to be hired. No one's going to be hired back in the year 0000. So date time would work, but we really don't even need the time portion. So we're just going to put a date as the data type for that column. And finally, we're going to do salary. So the salary, we have to think about the range. You know, how much could somebody possibly make at a job? If somebody made $1 million, that would be a pretty good job, right? If somebody made 100,000, they're doing pretty good too. So we know there'll probably be people around 100,000, and 100,000 we're talking about 100. So we're talking about 1, 2, 3, 4, 5, 6, and then usually on salaries you don't have pennies, but it'd be nice to store 2 more cents on there. I don't know in this case, do we need more than 2 decimal precision? Probably not. So there's 2 routes we can go. We can do a decimal, which will be exact storage, or we can do a float. A float will also give you exact storage to this level of precision. So it's really up to us. I would probably go with a decimal. Anytime we're talking about money, that's the first thing that goes through my mind is let's go with the decimal. And in this case, we have 1, 2, 3, 4, 5, 6. I mean, we may as well go a little farther. Let's go back to our sheet, and let's take a look at decimal again, and let's see when it changes storage. So it's a 5 byte up to 9 precision. And so if we use the 2 decimals, that gives us 7, which gives us 1,000,000. We may as well jump over to the next 9 bytes of storage and go with the biggest. So 19 precision would give us the 9 bytes. So we're going to do that. 19, and then we're going to store 2 of those after the decimal. And now we have all of our columns defined from a data type perspective. And this goes a lot faster once you know what you're doing with regards to data types and stuff. I'm just talking through all the little pieces here. The next question you should be asking is, can the column be null? So what does that mean? If we have an employee record and there isn't an employee number on it, how is any table ever going to relate to it? You know, we could do it by name or something, but this is what we think is the key of this table, is the employee number. So do we ever want this thing empty? So in the database terms, null basically means empty. Specifically, it means the lack of a number, the lack of information, actually. And so do we want to allow that in this column? We do not. We want to make sure something is in this column. So we are going to put in not null. And I'm going to pause for a second here and actually talk about one more thing. We talked about naming conventions. Well, there's also conventions to how you type SQL. What things should be in all caps, all capitalized, and what things should not. If you look at my crate table, it is in all caps. So everything's capital letters. Other SQL keywords should all be in capital letters too. If you go to a big company and they're real strict on the syntax, then we should basically type int as all capitals, and this not null should be all capitals, and it should look like that. I personally don't, I mean, everything color codes, and we have editors that color code everything. Doesn't make as big of a deal. But if you're having to edit SQL inside of a text editor where you don't get color coding, the all caps helps you pick out the keywords inside of the SQL syntax. So I'm going to leave this all lowercase for now, but you should know that, and if you go to certain places to work, you may have to capitalize those, and it might be good practice. I don't. It's not my habit. I like lowercase, but other Other places might like uppercase, and you'll have to adjust based off of what they need and what they want. So let's get back to the null issue. First name. Should everybody have a name? I think so. So let's put not null. Should everybody have a last name? Yes, I think so. Not null. Should everybody have a job description? Yes. Should everybody have a manager? Interesting. I would initially say yes, but if we had a full, complete employee table, there's always going to be that one person at the very top that doesn't have a manager. They are the top of the chain. So in this case, I'm just going to say yes, it can be null. And we're going to come back. We may have to come back to that and visit that again. If it can't be null, then we're going to have to take the CEO or the very top of the employee table, and we're going to have to figure out what to put in there for them, because we won't be able to allow a blank. So we're going to leave that one null. And the hire date, what should we do with that one? Maybe we don't have everybody's hire date, and so we're going to go ahead and allow that one to be null also. And then salary, maybe there's certain people's salary that they don't want to put in here, and so we're going to leave that one null also. All right, so now we've defined all the columns. We've named them, we've defined the data types, and we've determined if they can be null or not null. What is our next step? Okay, what is the unique column? All right. So we've already talked about this a little bit, but employee number is our unique column. And so in order, what we want to do here is we actually want to create a constraint on it that makes sure that it's unique. And what we want to do specifically is we want to call it our primary key and say this one column identifies a unique row in our table. And let's do that now. Now the syntax for that is constraint. And we want to talk about naming conventions again, because the next thing here is to name the constraint. And I'm going to call it PK underscore employee. And so the naming convention here is PK stands for primary key. And then we put an underscore and we put the table name. So this is the primary key for the table. There are different naming conventions. Again, like I said, you can go look and we can probably find primary keys over here. And they used the primary key, the table name, and then the column that's the primary key, business entity ID. So we could follow that by putting an underscore and employee underscore number. And that would tell us that this is a primary key for the employee table with the employee number column. And then next we need the keyword of primary key. You'll see it light up blue. And then we need to put the actual column in here. So all we did is we said we want a constraint. We want to call it this thing here. It's going to be a constraint of a primary key. And now we need an employee number as the column. All right, so now we've got the uniqueness here. Now there's one more thing I want to do that I didn't add in here that I need to add. Oh, no, we need to go backward, sorry. And we need to go back to, will this table relate to other tables? And this is a unique one because this relates back to itself. The manager number actually is an employee number and should relate back to itself. So we're going to put another constraint on here that identifies that relationship. So anytime that we put a manager number in, that manager has to also be an employee. And so let's do that. And we're going to start with the keyword constraint again. Now instead of PK, we're going to name it, and now instead of PK, we're going to say FK. and we're going to tell it this foreign key. We're going to say employee is the table, and we're going to say what column is the foreign key, manager number. Now, as you can imagine, instead of primary key, we actually put foreign key. And now we have a couple of extra clauses here. Now we gotta identify our foreign key column. So this is gonna look just like the one above it. But our foreign key column is manager number. But this foreign key, whenever you have a foreign key, it actually has to relate to a primary key. And so that's the whole relationship here. So we have to say that it references another table column pair. What's going to reference its own table here? So we're going to say it references the employee table, and it's going to reference this employee number column up here. So we need to put that in there. All right, so now we have the relationship to itself. Now, did we answer all of our questions? All right, where to put the new table? So we're going to put this in the HR database. What to name it? We named it the dbo.employee table. How big is the table? We determined that there weren't over 100,000 records in it, so it's a somewhat small table. Will the table relate to other tables? Yes, at least relates to itself. We know because we have a manager-employee relationship, but there might be other tables that need to relate to it, and hence we put in a primary key, and we have a foreign key. Then we went through what columns need to be in the table. We named the columns, we did a naming scheme. What type of data, we went through the different data types. We checked on each column, can they be null or not? And what is the unique column? That was our primary key column. The last question here is, who needs access to the table? So the table, there's always someone that needs access to it, right? Either an application needs to write to it, or an application needs to pull from it, or you have an ETL that has a service account that needs to run and have access to it. And so this is always good. If you're creating a view, maybe there's going to be business users that can actually run the view. And so the final piece of this would be to have some kind of grant statement in here. And you could say grant, insert, update, delete, select, to, and what's our table? It's employee. There's two clauses on this. On dbo.employee, and then to, and then whoever you want to give access to. And so that would be in here. And a lot of times when you are storing your scripts for production purposes or whatever, you would have some grants in there. So if you ever had to recreate the table or something, they would know who it's granted to. All right, so we answered all the questions. Let's go ahead and try to create this table. So we said we're going to create it in the HR database. If I look down here, we are in the HR database. We are going to have a problem though, because at the very beginning of this training, I think we created a table that just had one column. And so it's sitting in here as DBO employee. Well, let's get rid of that. Oops, I'm going to get rid of the table. I'm going to delete that. So we just need to drop it. We can type it in or we can right click there. So I'm going to drop table dbo.employee. Now it's gone. Okay, so we no longer have it in here. And let's go ahead and let's run our new statement. Execute it successfully. Let's take a look at what it did. DBO employee. There's all of our columns. And here we can see we have our primary key. We have our foreign key. If we go down here, we can see that they're named in a way that we can understand them. If you actually, there's other ways of creating the primary key and foreign keys. But if you create them and don't name them, the system will name them, and then you can't understand what they mean just from the name. You have to go in and look at them. Are there any constraints? Nope, no constraints. We could put a unique constraint on there, but the primary key should do that for us. And I think that is our table. So at the beginning of this training, I said that you'd be able to understand each of the different lines inside this create table statement and why we named them, where we put it, all the different questions we went through. So this is the final product. As always, if you find this helpful, please leave a comment below, click the like button, or subscribe to my channel. You can always visit me at SQLtrainingonline.com or LinkedIn, and I hope you enjoyed this video.